Hello, in this video I make a little conclusion of the plans of programming here. And I have this TRIPS code program, and I have created a very unique and useful system in the language that has subdivision surfaces and plus the curves around the edges or inside the edges. And this is not a modeling program, and I have also plans to make another program based on this C code that maybe has CUDA or graphics capabilities to speed up something. Another way I could speed up also this C code with threading, multi-threading, but with the multi-threading it is the case that the new code must be in finished state before you go to multi-thread it. And it makes a branch in the development then. But what to say about those curves and those subdivisions? And we could simply check out this code here. What is this subdivision? And we see that this is a very long process for subdividing and coming up with those curves in the. You could form those curves with vertice weights and so on. You could weight the whole curve against the subdivision surface and mix subdivision surfaces with curve influences. And we see those are called then patches when curves are applied. And this code goes on, and we could assume that this is not very fast when something bigger is there. And another thing that I wish to say is that this is not a modeling program. You just import whole ready objects and then you apply those curves where you see fit. But if it was a modeling program, that this is the ideal world where your dreams come true, the really magnificent modeling program where you can create networks of curves and make those into patches or mix the ready-made polygons with those new curve types. And if we think of a modeling program, then the core part of a modeling program is of course is the undo system, if you think of it. And this program has no undo system in it. It has only the one level cancelling of a certain action, but not any undoing. And what about this undo system? If you think of it, how it should work. Let's imagine a simple array of vertices, for instance, or array of polygons. Then those actions that we take on those polygons should be then undoable. And if we move a vertice or do something else, then we can undo this action via opposite moving or counter vector moving. But or anything that we do based on moving. But if we change the geometry, then it becomes instantly complicated, because if we add geometry, then of course we add to the end of the array of those polygons, the new polygons there. but the complexity comes of the deleting action. If we delete something in the list and it's not in the end of it, then of course we end up with a list with a hole in it, or holes. We just observing the deletion of the one polygon, and then the hole or this polygon is missing in the midst of the array, and we wish to undo this action also later. Then it is not good to start moving those, rearranging those arrays and all those indices and all those connected systems to get new indices and pack those arrays compact. It's not useful in the sense of undo system. Then we just leave this hole into the array and label it as deleted. And when the undo stack goes on, then we, in certain moment in time, then we label this hole vacant. And this vacancy means that the new elements, that as they are appended, scan the array for vacant holes or vacancies, and write the new polygon into this vacant space. Of course, later in the stage we wish to compact those arrays also, but those are the separate systems that then you just start compacting and optimizing those arrays, and this is not so much related to the undo system. After compacting you lose probably the undo system, or those vacant arrays then move into vacancies move into the end of the array, for instance. Then those they are compacted naturally then if new polygons get appended. And of course it is not so simple as I describe it here, because all those actions are interconnected. When we delete, for instance, a batch of polygons, probably we end up deleting some vertices in the process, or if any tool is executed, then multitude of different actions are taken, and those are all compacted then into one single undo action. But if you observe only at the programmer's level the single array, then this deleting and appending, they are sort of complicated system that needs very close attention. And if I talk this, then we just think of a program that has no subdivision in it. But if I talk about this my program here, that this program, then those subdivisions here really don't use. They cannot use those such type arrays that have holes in it, because they use compacted arrays where the next subdivision level communicates to the previous subdivision level. And for instance, if we get next level of vertices, then the vertice count is much larger for the next level. But some vertices are the same as in the next level, so they are intercommunicating, and they are ordered in the arrays. They are not randomly in the next subdivision level. So for the edges and the polygons also. And this is the efficient and meaningful way to subdivide geometry. And of course, if we think we should go into CUDA course or subdividing on the GPU board, then we need especially this order, and through the indices we we should then search out those relevant polygons for the next subdivision level. And how this then the undo system should work with those compacted versus the compacted mode. And this is the very, very important and difficult question in programming. And what should I plan to do? Probably it is in the GPU there still needs to be a compacting for those subdivision surfaces. Before they go into GPU, the system compacts those arrays and sends them. But I really don't know how efficient those techniques are and how they can be made into a real thing.